Welcome to Brain Vision.
So continuing on with our work on the physical chemistry material, we're continuing to look at all sorts of equations related to temperature, volume, pressure, and things of the like. So the first thing we need to do is look up the vapor pressure of water at 15.6 degrees Celsius. That is 13.290 millimeters of mercury. So because the outlet of the compressor-condenser is saturated, we can calculate the mole fraction of water in air. So what we have is Y2 is equal to 13.290 millimeters of mercury divided by 3 atmosphere multiplied by 760 millimeters of mercury divided by 1 atmosphere. We get a value of 0.0583 moles of H2O, moles of air. So we can assume N1 is 100 moles of feed, so we can do a water balance around the condenser compressor. On a new page we have 100 moles of air multiplied by 0.10 mole of H2O, divide that by mole of air is equal to 0.00583 mole H2O divided by the moles of air multiplied by N2 moles of air. And then we add N3 moles of H2O. So we can see that a lot of these values cancel: moles of air, moles of air, moles of air, moles of air. So what we can do is solve for N2. We're at 90 moles BDA, 0.99417 N2 moles of BDA. Solve for N2. We get 90.53 moles of air. Substitute N2 into the water balance equation to solve for N3 then. We get N3 is equal to 9.47 moles of H2O in the liquid state. So we can calculate the mole fraction of water that we have then condensed. So we have the fraction condensed, FC, is equal to N3 divided by N1. So what we have is FC is equal to 9.47 divided by 100, because remember we assigned N1 100. Fraction condensed is 0.0947. My stop was in the wrong place. We've got 0.947. Okay, so continuing on. At the outlet of the heat, the temperature we have was 100 degrees Celsius. We look up the vapor pressure of water at 100 degrees Celsius, and then we can take a look at the partial pressure of water at the outlet. So P4, we'll assign that is equal to Y2 multiplied by P4. So P4 is equal to 13.92 millimeters of mercury. So we can calculate the relative humidity at 100 degrees Celsius. That is Pi divided by P star T multiplied by 100, get 1.749%. So the relative humidity of the air at 100 degrees Celsius is 1.749%. So next we can take a look at the ratio of the outlet air volume and the inlet air volume. That can be expressed by the ratio of the ideal gas law. So on a fresh page, what we have is V4 divided by V1 is equal to N4 divided by N1 multiplied by T4 divided by T1 multiplied by P1 divided by P4. So what we get is ratio of V4 to V1, that is 0.310, so the ratio of feed air to the outlet air is 0.310 meters cubed. Outlet air at 100 degrees Celsius, meters cubed, feed air at 90 degrees Celsius.